Welcome to the project demonstration of optimal interconnection device for distributed energy resources for customers. So here the main application of this project is whenever we are not getting a power supply from the main source as a transformer, then the auxiliary transformer will provide the power supply to the customer without any interruption to the power source. So that's the main application here. So in order to execute this application, we need to continuously monitor the availability of this voltages, means the power from this main transformer, and that will be measured by the microcontroller. So this is switch. Manually we are going to make a fault to this one. So here we are providing the two inputs. So this one is the main transformer and this one is the auxiliary transformer. The two outputs from this main transformer and auxiliary transformer is connected to the one load through this relay. The relay is nothing but we are using the single through double pole switch. So double pole is used to switching between the main transformer and auxiliary transformer. So it will get the main power supply from this source grid. So the 230 volts will be stepped down to the 12 volts. In real time directly it will go to the 1:1 transformer, but here for demonstration purpose we are using this 12 volt DC load. For that purpose we need to convert the 230 volts AC to 12 volts of DC. For that purpose we are using the two transformers, and the output of the each transformer is input to the regulated power supply board. So here also regulated power supply board are present. So on every regulated power supply board we have the three stages. So this one is the rectifier and filter and regulation, and here rectifier 4 diodes, and filtration the capacitor, and 2 diodes with a unidirectional current flow for the load directly with LED indication. And the main processing unit microcontroller required 5 volts. So the 12 volts DC directly from this one is connected to the relay. So here you can see this. So connected to the relay. So two positives, negative directly connected to the load. So the phase also getting connected from the relay. So whenever this main source available, will be switching to the main source, and whenever this is not available, then the auxiliary load will transformer will be connected by switching this load phase to the auxiliary transformer phase directly. And at the same time we'll get the audible alert through the buzzer, and the status continuously monitoring on the LCD which transformer was connected, and this is a main switch. So these are the main components wise and power flow wise execution explanation. So now coming to the main components, as we discussed initially, let me go through the once again components wise. The main transformer, auxiliary transformer, the regulated power supply board for the main transformer, regulated power supply board for the auxiliary transformer, and relay to switching between the main and auxiliary transformer, and buzzer board to get the audible alerts, and the microcontroller continuously measuring the input and output modules. Input is switch and output module is 16:2 LCD screen, buzzer board, relay board, and these are the main input output connections. Let's check with the demonstration. So when we on the SIP, so the main supply is off. Of this one, the main supply is on, backup is off, means the auxiliary backup got switched off now. So whenever we have this one, we can see that there is no interruption to the load power supply. Right, you can see the main power supply is off, backup is on, and we can check the status from the relay board also. The relay is on, nothing but the backup was on. At the same time the relay was off, nothing but backup is off. So this is the input from the main source to the microcontroller, the switch. This we are isolating the power supply to the system. So from here we are going to check the status. Right, thank you.